Hello guys, sorry to start the Lab 8 in this way. Because of the coronavirus thing, Lab 7 and Lab 8 was supposed to be cancelled. However, I feel like the permeability test is pretty important in civil engineering, so I still decide to introduce you this lab online. Hope you guys also find it helpful. Permeability is necessary for the calculation of the quantity of underground seepage through old stems and old retaining structures. The understanding of the method to measure the permeability is important to the stability analysis of these structures. So the objectives of this lab are to get familiar with the equations that govern the flow behavior in saturated soil, and then determine the coefficient of permeability of coarse-grained soil with a constant head test and a falling head test. The following are some background information. The rate at which water flows through a soil sample can be expressed using Darcy's equation. The Q here is the flow in unit time. K refers to the coefficient of permeability, while A is a cross-sectional area of soil in which the flow occurs. I is a hydraulic gradient between these 2 points, which equals to the hydraulic head loss divided by the distance between these 2 points. According to the Darcy's equation, the coefficient of permeability can be formulated like this. When it comes to the measurement of the permeability, two methods, constant head test and falling head test, were usually adopted. Constant head test, which is characterized with a constant hydraulic head, is best suited to determine the coefficient of permeability of coarse-grained soil. As introduced before, the permeability equals to the flow in unit time divided by the hydraulic gradient times the cross-sectional area of soil sample. Because the hydraulic gradient equals to the hydraulic head difference between these 2 points divided by the distance, then the permeability can be written as this equation. Here we time T both at the top and the bottom. Given that the capital Q here refers to the quantity of water connected in time T, the permeability is finally expressed as this equation. Because the cross-sectional area of soil and the distance between these 2 points can be easily measured. So now if we know the quantity of water connected in time T and the hydraulic head difference between these 2 points, we can easily calculate the permeability of our soil. In the lab, we will usually use the connection tube to measure the amount of water, like this. In contrast, the falling head test is more suitable for fine-grained soil. This test is based on the amount of water flows through a soil sample, which is expressed like this equation, equals to the quantity of water reduced in a standard pipe, which is written like this. So the K can be expressed as this equation. Because the quantity of water reduced in the standard pipe, VE equals to the cross-sectional area of the standard pipe times the hydraulic head difference. So if we time the hydraulic head difference both at the top and bottom, we'll get this equation. If we know the quantity of water reduced in the standard pipe, VE, and the drainage time, we also can get the permeability of the soil. Usually we use this setup to conduct the constant head test. Some of you guys noticed I was preparing this test in the lab 2 weeks ago. First of all, I will introduce this device briefly and then show you the water flows in the system. This is a permeameter cell, which is filled with saturated soil. These two taps were connected to the piezometers, and the distance between these two taps is known as L. These piezometers are used to measure the hydraulic head at certain points. The left one is connected to the head tank, while the right one is connected to the overflow funnel. This crank is used to adjust the place of the head tank. In this test, we need to change the elevation of the head tank at least 3 times to repeat the test. Now, if we turn the pump on, water will be pumped into the head tank. The water level is raised to the height of overflow tube slowly. Because of the existence of the overflow tube, the hydraulic head in the head tank will remain constant. This is also why it is called constant head test. The hydraulic head difference between these two taps can be obtained by these two piezometers. When the water comes to the overflow funnel and reaches to the top, it will force to the connection tube. At first, the return valve will remain open to allow water to flow back to the water tank. Now only the parameter Q and T are unknown. To obtain these two values, we need to turn off the return valve and start the timer. Okay. If the amount of connected water reached to Q, record the time, and then the permeability can be calculated using this equation. After that, we need to adjust the elevation of the head tank and repeat this test twice. The falling head test can also be conducted with this device. When the system is stable, we need to record the hydraulic head difference between the head tank and the overflow funnel. Then we need to turn off the pump and start the timer. This will allow the head tank to empty itself. When the amount of drained water reaches to VE, which is usually 2 liters, record the time and the hydraulic head difference, H2 here. Thereafter, we can also calculate the coefficient of permeability. Please keep in mind the permeability obtained by the above-mentioned two methods is related to the temperature of water. So, in order to get the permeability of soil at a temperature of 20 degrees, we should also measure the temperature of water during the test. Then, the standard permeability can be calculated using this equation. The coefficient here can be obtained by checking this table based on the temperature of the water. These are the final two tables. We need to calculate the coefficient of permeability of soil with the obtained data. Because you guys cannot do this test, I will provide you with some data on Brightspace. Still, you guys are supposed to write a lab report and submit it within 1 week. Okay guys, this is the end of the lab. If you have any questions, please email me. I will try to reply you as soon as possible.